Hi everyone, my name is Soumojit Chatterjee and welcome to TLE Eliminators. Today we will discuss the first 5 problems of today's Codechef contest. So before we start, I would just like to confirm whether my screen is visible and my voice is audible or not. Can someone quickly confirm in the chats? Okay, great. So before we start, I would like to quickly tell you all about the CP31 sheet.
क्या हुआ?
So this is the
हाँ यार,
newly
तबीयत खराब हो
launched.
गई मेरी। जॉइंट में
Just
दर्द हो रहा है। मुझे लगता है पानी आज नहीं किया तो उससे खराब है। वो तो बहुत वाली पे अंदर एक रहने वाला है।
yeah. So basically, this is our newly launched version 2 of our CP31 sheet. So for all of you who are not aware, so this is a sheet of 31 handpicked problems for each rating in the rating range 800 to 1900. And all of these problems are very carefully chosen so that every problem teaches a very unique idea. So here is the sheet, and you can look at that there are 31 problems for each of the problems in the rating range 800 to 1900, and the sheet has been upgraded with a new interface. So you can automatically sync your progress directly from Codeforces here, and then there is a dedicated discuss section where you can discuss doubts regarding any problem. Apart from that, there is also leaderboard where you can actually synchronize your Codeforces profile, and you can look in the leaderboard where you stand among your friends. So apart from that, every week 7 to 8 problem video solutions of these problems are released so that you do not need to waste time finding solutions or searching for the right set of problems to practice. Okay, so with all this, let's move on to the first problem of today's PCT. So this is the first question. Its name is clothing store. So the question says that chef owns a clothing store and has a limited number of t-shirts in different sizes. Okay. So there are 3 sizes available: small, large, and extra large. And the count of these t-shirts which chef has is X, Y, and Z. Okay. Then there are A people who wear small, B people who wear large, and C people who wear extra large t-shirts. That's fine. Now each person is happy if they receive a t-shirt in their desired size. However, Chef has a magical tailoring machine that allows him to convert larger shirts into smaller ones. That means an L shirt can be converted into an S shirt, and an XL t-shirt can be converted into an L or an S shirt. That's fine. Now it is also said that conversions are one way and irreversible. That's fine. And each conversion maintains a 1:1 ratio. That is, one XL shirt can become exactly one L or one S shirt. Chef wants to distribute the t-shirts optimally, making conversions if necessary to maximize the number of happy people. So can we determine the maximum number of people who will be happy? Okay. So let me explain the problem statement. So the problem statement says that so the problem statement says that chef is given 3 integers: X, Y, Z, and ABC. Okay. So what is X, Y, Z? X, Y, Z is basically the count of small, medium, small, large, and XL t-shirts. So it is small, large, and XL t-shirts available. Okay. So this is the count of t-shirts. And A, B, and C is basically the demand. So we can think about that X, Y, and Z is basically the supply of t-shirts which is available to us. So this is the supply which is available to us. And A, B, and C is basically the demand. How many people need how many t-shirts? Apart from that, it is also said that what we can do is, if we have many XL t-shirts say available, but there are many people who wear small t-shirts. So we can cut out. So there is a tailoring machine where we can cut these XL t-shirts into small t-shirts and give it to these people who need small t-shirts. So we can cut t-shirts of larger size to t-shirts of smaller size. And the question is simple. How many people can we make happy? So a person becomes happy if he gets a t-shirt of his desired size. And the question is, how many people will finally become happy? So maximum number of people whom we can make happy. Whom we can make happy. So that is what the question asks. Okay, so is the problem statement clear? A quick yes if it's clear. Any doubts with the problem statement? Okay, great. So if the problem statement is clear, so there is one observation which you need to make, which is fundamental to the solution. And that is simple. So the idea is that you have some small t-shirts, some large t-shirts, and some XL t-shirts. Now, look that there is no choice with these small t-shirts. So suppose you have 10 small t-shirts. You have 10 small t-shirts. And then there are 7 people who wear small t-shirts. So the value of A is 7. So what you can basically do is, out of these 10 t-shirts, you can give 7 t-shirts to these 7 people, and the rest 3, you have no other choice but throwing them away. Why? Because these are small t-shirts, right? Right. You cannot increase their size and give it to large or XL people. So these small t-shirts, you can only give it to people who wear small t-shirts, and rest you have to throw them apart. So that means it makes sense distributing t-shirts in this order. So first, why not distribute small t-shirts first? So when we will distribute small t-shirt, the advantage is that we know exactly how many t-shirts do we need to give. So if there is so we will distribute in the order of size. So first we will try to distribute all the small t-shirts. Then we will try to distribute all the large t-shirts. And then we will try to distribute all the XL t-shirts. Okay. So what is the idea? So I have small t-shirts. I have X, Y, and Z. Okay. So these are the count of small, large, and XL t-shirts. Okay. And suppose A, B, and C is the number of people who need to wear these t-shirts. Now, first we try to distribute these small t-shirts. When we will distribute these small t-shirts, these t-shirts can go to only those people who wear small t-shirts and no other people. Similarly, when we will distribute these large t-shirts, it can go only to these bunch of people, either to the people who wear small t-shirts or to the people who wear large t-shirts, because this size exactly fits. So it can go to these people, and we can use the tailoring machine to shorten its size and distribute it to people who wear small t-shirts. Okay, that's fine. Now tell me one thing, that if I want to distribute, say, these X number of t-shirts to these A number of people, exactly how many people will become happy? Any idea? Exactly how many people will become happy if I have to distribute X number of t-shirts to these A number of people? If you think about this, so actually, the number of t-shirts you can actually distribute under any circumstances is nothing but minimum of X comma A. That is basically, you cannot distribute more than X t-shirts, right? Because the number of t-shirts you have is X. So you cannot distribute more than X t-shirts. Similarly, you cannot make more than A people happy because there are at most A people. So that means the number of people which you make happy is basically has to be less than both X and A. So it is basically bounded by the minimum of both X and A. And so it has to be minimum of X and A. Think about it like this, that if you have 7 t-shirts and you need to distribute it to 4 people, so only 4 people become happy. So that is the minimum of 4 and 7. Similarly, if you have 5 t-shirts and you need to distribute it to 8 people, then only people will become happy because you have only 5 t-shirts. So that is the reason if you need to distribute X t-shirts among A people, minimum of X comma A people will be happy. Okay. So you know that these number of people will be happy. So that means these number of t-shirts you have distributed and these number of people have got the t-shirts. So what is the idea? You basically reduce X with this number minimum of X comma A. Okay, fine. So now you have an updated value of X, which is basically the number of small t-shirts you have and the number of people who still want to wear small t-shirts. Now you come to Y and you do the same thing. You try to distribute this to the people who need to wear large t-shirts. How many people can you distribute? You can distribute it to minimum of Y comma B people. That many people will become happy. So again, you update the values of Y and B and keep on continuing the results. After you distribute Y to these people who wear large t-shirts, go and try to distribute Y to these smaller t-shirts, to these smaller people, A. And similarly for this Z, in the same order, you first distribute it to C, then distribute it to B, and then distribute it to A. So basically the idea is, that you have t-shirts which are X, Y, and Z. These were the count of the t-shirts which we call as the supply. Okay. And then we have people A, B, and C, which is basically the demand. How many people need to wear things? And the idea is simple, that you distribute t-shirts in the order of increasing size. But when you are trying to distribute shirts of larger size, distribute it to people in decreasing order of their demand. So that is the basic idea. Let's have a look at the code once, and then I think it will become clear. So see what I've done. So I've basically taken 3 integers, which is basically my supply integers, and 3 integers, which are basically my demand integers. So basically the supply integers are X, Y, and Z. The demand integers are A, B, and C. Okay, fine. Now I'm trying to distribute the t-shirts in increasing order of size. Okay. So initially my answer is 0. So I have not yet distributed any t-shirt to anyone. Now I start distributing. When I start distributing, so look, what does I indicate? I indicates which t-shirt. So basically here, I indicates the pointer to my supply equation. So I indicates a pointer here. So here is the pointer I, and suppose here is the pointer J. Okay. Note that J starts from I and goes backward. J cannot start beyond I, because if you are trying to distribute t-shirts of say L size, you can distribute it to only those people who want t-shirts of L or S size. You can't distribute it to people who want t-shirts of XL size, right? Because you cannot increase the size of a t-shirt. So what do? You start from J equals I, and then you keep on decreasing the value of J. At every step, you know how many people how you can make happy. That is exactly the minimum of both of them. And then you increase and update the value to its answer. And then you know that, okay, take is the number of people whom I have distributed the t-shirts. So the value of take is basically decremented from both the supply and the demand. So finally, this loop terminates and you get the value of the answer. Okay, so any doubts? So is the idea clear? Okay, great. So if it's clear, then let's move on to the next problem. So this is the second question of the contest. So the question says costly summit. It says that chef is going to meet N people. Each person speaks one of the 5 languages A, B, C, or C, D, or E. And chef does not know any language at the start. To communicate, he has 2 options. Chef can learn a language for a fixed cost C. And once he learns a language, he can talk with everyone who speaks that language. So that is fine. Otherwise, chef can hire a translator to help him. The cost of hiring a translator goes up each time he uses one, no matter which language it is. For example, his first use costs 1 unit, his second use costs 2 units, and so on. Okay. So now it says that you are given a string s of, just a second. Yeah. So the question says that you are given a string s of length n, where si represents the language spoken by the ith person. Your task is to find the minimum total cost for chef to talk with all n people. Okay. So let me explain the problem statement once. So the question says that there are n people who speak n languages, each from A to E. So suppose you have some string given. So suppose you are given this string A, B, C, B, D, E, A, B, C. So what does this represent? This is basically a list of people such that the first person talks in language A, the second person talks in language B, the third person talks in language C, and so on. Okay. Now chef wants to talk to each of these people. Okay, fine. Now what can he do? He can do two things. The first thing which he can do is he can learn any language using a cost of C. So he can give cost equal to C to learn any language. Okay. So what does that mean that you learn any language? So that basically means that if you say learn the language B, so if you learn the language B, then you basically incur a cost of C, and now you can talk to all these people who talk in this language B for free. You need to add no extra cost apart from giving this cost C to learn the language. Okay. Otherwise, what you can do is you can hire a translator. Okay. Otherwise, what you can do, you can hire a translator. But you can hire a translator, but the cost you need to pay to use this translator is a bit weird. So whenever you are using this translator for the first time, you need to pay a cost of 1. But for the second time, you need to pay a cost of 2. And every time, basically, the cost of using the translator increases by +1. Okay. And now the question asks, what is the minimum cost you need to finally talk to all the languages, to all the people? For example, think about this. Suppose this is my string A, B, C, D, B, A. Okay. And suppose the value of C, which is basically the cost of learning a language, is given as 4. Then if I ask you, what is the cost which you need to pay if you decide that, okay, you will learn B and C? Just a second. So suppose I tell you beforehand that, okay, you need to learn these two languages B and C. Then what is the cost the chef needs to pay? So think about this. First of all, he is learning two languages. If he's learning two languages, then he need to pay the cost of C twice. So that is basically the cost of learning the languages. Now, once he has learned the languages B and C, he does not need to pay anything to talk to these people who speak in languages B or C. What remains is the other language. Now, for all these other languages, he needs to pay a cost of 1 to talk to a cost of 2 for D, and a cost of 3 for A again. Total cost, this is 4 into 2, which is 8, and the sum of these three numbers. So that is 8 plus 6, which is equal to 14. Okay. So depending on the choice of which languages I will actually learn, my cost to actually speak to all the people may differ. And the question asks that, okay, what is the minimum cost you need to actually talk to all the people? Okay, so is the question clear? Any problem with the question? Okay, great. So if the question is clear, so the basic idea behind the problem is that think about how many choices you have. So you have 5 languages, right? You have 5 languages. Now think about any language. So if you think about any language, consider the language A. Okay. So there are two choices which you have. There are only two choices which you have. What are the two choices? there is one choice that you don't learn this language. Okay. And the other choice is that you learn this language, right? So there are only two choices for A. Similarly, there are 5 languages. For every language, if you have 2 choices, what is the total number of choices you have? You have 2 to the power 5 choices, right? So that is basically you have 5 languages A, B, C, D, and E. And language, for every language, you can either learn it or you may not learn it. So there are 2 choices uh, for A. There are 2 choices for B. Similarly, there are 2 to the power 5. That is basically you have 32 choices to learn a set of languages. Okay. So what if I iterate over these 32 languages? What if I iterate over these 32 choices? If I iterate over these 32 choices, then basically my choice of which languages I will learn and which languages I do not learn gets fixed. After that, I can simply iterate over the string and find out what is the cost, what is the cost to speak to all the people, right? So don't you think that actually this problem can be solved? This problem can be solved in big O of 32 into n time by simply iterating over all the possible choices. So why n? You need n because you need to iterate over the string every time to actually find the cost. And why 32? Because there are 2 to the power 5 or 32 different combinations of choices which we can have to learn a subset of languages. Okay, so is the idea clear? Yes, Ravi, there is translator only for one person. There is just one translator who can translate all the languages, but the cost to translate increases by 1 at every step. So even if you look at the problem statement, so this is what it says. Chef, the cost of hiring a translator goes up each time he uses one, no matter which language it is. So actually the language does not matter when we are using the translator, but the cost of hiring the translator goes up each time, exactly once. So if I show you the code, so the idea here is pretty simple. So what I've done, so I've taken N and C as input, and then I've taken the string as input. Okay. And now here is this answer variable where I will finally print the minimum cost required to speak to all the people. Okay. Now I have initialized answer with 5C. Because I have initialized answer with 5C. Basically, what is 5C? 5C is the cost to learn all the languages. So I learn all of them, A, B, C, D, and E. Okay. So if I learn all of them, then the cost is 5C. And I know that my answer can never be more than 5C. Because by just paying 5C and not using the translator at all, I can actually solve the problem. So my answer at max is 5C. You can also initialize this with infinity and find the answer. Everything works. Okay. Now here I'm iterating over from I equal to 0 to 32. So from I equal to 0 to 32, basically I represents the choice. As I said that there are 32 choices, right? So usually in all these problems where there are for say 5 binary choices, then we basically iterate a loop variable I from 0 to 32. So what does that mean? So remember that you can represent any number from 0 to 32 as a bunch of 5-bit numbers, right? So for example, any number say 17 can be thought of as 10001 in its binary form, right? And the beautiful part is we can interpret this as that, okay, so we can interpret this as this like this, that okay, that there are 5 languages A, B, C, D, and E. What does 17 mean? 17 mean that okay, since this is 1 at this position, that means you learn language A, you learn language E, and you choose not to learn B, C, and D. Okay, so this is basically a choice which you can make. Similarly, different integers, say 8 or 13, will represent different choices in their binary form. So if you iterate from 0 to 32, you are basically iterating over all possible choices from, so you are basically iterating over all possible choices from 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, and actually finding the minimum cost required. Okay, so this is what I've done. I have iterated I from 0 to 32. And here this is the cost variable where I will store the cost. And this is the translator variable where I will store the cost required to use the translator. Okay. And then I just iterate over the languages and then I try to find out that, okay, in this I, how many bits are set? Because the number of bits set in I is basically the number of languages I'm learning in this case. So basically I add a C every time to the cost because I need to incur a cost of C to learn a language. After that, I basically iterate over the string, and this condition basically ensures that I have not learned the language yet. If I have not learned the language yet, then I have to use the translator and and add up the cost of the translator to cost, and I do a translator plus plus to basically ensure that the cost of translator increases by 1 every time I use the translator. Finally, I update my value of answer to the minimum of cost and answer to take the minimum answer required. And I finally print the answer. Okay, so is the solution clear? Yes, Vinit, I think we can use recursion here. Though basically the idea remains the same, that you need to iterate over all the possible 32 choices. We can actually use a recursion here, like we can make 2 recursive calls every time between like once where we learn a language and once where we do not learn a language. That works pretty fine. Okay, so any doubts, or else we will move to the next problem. Okay, great. So if that is clear, let us move to the next problem. Okay, so the question says same and. So the question says that you are given 2 non-negative integers n and m, where n is less than m. A beautiful sequence is defined as a sequence S of k integers x1 to xk of distinct non-negative integers, each at most m, that satisfies the following properties. Okay, so xi must lie between 0 and m. So every integer xi is at most m, that is given. Xi is not equal to xj. So basically it ensures that all the terms are distinct. And the bitwise AND of any two integers xi and xj is equal to n. Okay. And the length k is greater than 1. Okay. So it says basically that given two non-negative integers n and m, the task is to print the longest beautiful sequence. If there are multiple sequences with the maximum possible length, you may output any one of them. And if no beautiful sequence exists, then output -1. Okay, great. So let me explain the problem statement once. So the question says that you are given two integers n and m. Okay. And the value of n is less than m, that is given. Fine. Now you need to print k integers x1, x2 till it goes till xk. And there are few properties which you need to hold while printing them. First of all xi must be positive, so it should be greater than or equal to 0. And it should be at most m. So this is the first condition. So everything is at most m. The second condition is that all these integers should be disjoint. None of them should be equal. So xi should not be equal to xj. Okay. And the third condition is you take any two integers, xi and xj, you do the bitwise AND of these two integers xi and xj, that must be equal to n. Okay. So there are many sequences possible in the world which satisfy all these conditions. You need to print such a sequence which is of maximum length. So k should be as large as possible. Okay. So we need to print a sequence of maximum length. So basically we need to maximize the value of k. If the maximum value of k is also 1, then we will print -1. That is what the question says. Otherwise, we basically print the sequence. Okay. So is that clear? The question is clear? Okay, great. So if the problem statement is clear, let us try to build a solution slowly. So first of all, think about it. So the bitwise AND of any two integers is n. So think about n in binary form. So suppose this is n. Okay, and also let's think about m. So suppose this is n. So m is greater than n. So suppose m looks like this: 0, 1, 0, 0, 1, 0, 1, 1, 0. Fine. And suppose n looks something like this: 0, 0, 1, 0, 1, 0, 0, 1, 1. Okay. Now we need to print integers x1, x2, xk such that the bitwise AND of any two integers xi and xj should be equal to n. Okay, that's interesting. That means think about these bits where n is actually 1. So these bits where n is actually 1, these bits should be 1 in the binary representation of all of these digits x1 to xk, right? Like I cannot have an xi. So my idea is that, okay, suppose n is this. So as we said that n is this 0, 0, 1, 0, 1, 0, 0, 1, 1. I cannot have an xi whose binary representation looks like this. I cannot have an xi whose binary representation looks like this, because then I will have a 0 here where n is 1. So that means if I take a bitwise AND of xi with any other integer, I will never get a 1 in this position. So I will not get equal to any time. So that means that in the binary representation of all the xi's, the number which is 1 here, that should be 1, that should be definitely 1 in all these xi's, right? So that means think about this. So how should the binary representation of an xi look like? So my idea is that the binary representation of xi, I do not care about these bits where n is 0. Like I do not know about them, but I know that okay, in these positions xi should be 1. Why xi should be 1? Because in these positions n is 1. So if n is 1, xi also has to be 1. Otherwise, the bitwise AND of two xi's and of xi with some other xj will become 0 at this position, which will violate our condition that the bitwise AND of any two xi's is equal to n. Okay. So, okay. So is this condition clear? Any doubts with this condition? Okay, great. So if this condition is clear, so let us try to think about one more condition. Okay, so let me write the binary representation of n once again. So I have n whose binary representation, which we were discussing in the last page, looks something like this, for example. Okay, and we are already sorted with these positions. We know that these positions are 1, so they have to be 1 in all xi's. But what about this position where say the bit of n is 0? Note that if the bit of n is 0, it may happen that there exists some xi. It may happen that there exists some xi which is 1 at this position, right? Because if it is 1 at this position, then it may be possible, because it may happen that when I'm trying to take the bitwise AND of xi with some other xj, the bit of that bit of other xj is 0, which makes the bitwise AND at this position equal to 0, and so the entire bitwise AND becomes equal to n. So that is fairly possible, right? But think about this. Can I have two different integers xi and xj which have 1 in this position? Can I have multiple integers xi and xj which are 1 at the exact same position where the bit of n is 0? Can I have that? Anyone? So can I have multiple xi's which are uh, actually, I cannot have two different integers xi and xj which are 1 at a position where n is 0. Why? Because think about this, that suppose I have two integers xi and xj which are 1 at a position where n is 0. Then what would happen if I take xi bitwise and xj? If I take xi bitwise and xj, it will also remain 1 at this position, right? Because this is 1, this is 1. So the bitwise and of 1 and 1 will remain 1. So at this position, xi and xj will be equal to 1. But at this position, n is equal to 0. So that means xi and xj will not remain equal to n. So what does that mean? That means that whenever I have a zero somewhere, I can have at most one integer. I can have at most one integer, which is 1 here. And rest all other xi's have to be 0. So is that clear? Yeah, exactly. So that means suppose my n is this. Okay. So 0, 0, 1, 0, 1, 0, 0. So which x's can I actually make? So my x1 can be, okay. So first of all, I can always pick xn, like this n as my x1. So I can just copy this up, right? So I can just say that, okay, my x1 is this exact same thing. So that does not create any problem because I am taking n. So the bitwise in and of n with anything else will remain n, other unless we do not mess up with these bits where this is 1. So I keep x1 as n in itself. But then what can I make at x2? So suppose I make x2 like this. So these bits which are 1, they have to be kept 1 throughout, right? Just a second. So these bits which are set in n have to be set at x2 also. They have to be set at all xi's. And suppose you keep a 1 here and rest 0 here. So suppose this is my x2. So remember, now when we will try to build x3, I cannot keep a 1 here. I have to keep a 0 here. Why? Because if I keep x1 at this position, then the bitwise AND of x2 and x3 will not be equal to n, and it will violate the condition. Okay. So if the bit of x2 is set at this position, x3 has to be kept 0. So I can keep this 0. So this bit now let me keep 1. And these bits I am forced to keep 1. So rest let me keep 0. Okay. So my idea is that since I need to maximize the number of terms, I have no choice with these bits which are kept 1. So these bits which are kept 1, I have no choice. I have to keep them 1 at all positions. Okay. Remaining integers, what do? I make them 1 by 1. So I have one integer xi where this is 1 and rest all zeros. I have one integer xj where this is 1 and rest all zeros. I have one integer xk where this bit is 1 and rest all zeros. So that is my idea. Apart from that, I also have this integer n where I basically keep everything 0 except the bits which are 1, obviously. So that would maximize my length of k. So by this way, I can take as many terms as possible. Why? Because instead, if I do something like this, that if I take this, an x4 like this, where 0, I make multiple zeros to ones at the same time, then I will be basically destroying the number of ones where I could keep the integers, right? So basically, instead of taking this x4, I could have added two integers where one was there at this position and the other integer where one was there at this position. So I basically destroyed two positions using this integer here. So I will not add up this integer. So I will not use this integer. Rather, what would be my idea? My idea would be simple. My idea would be that, okay, if n is something like this, it is 0, 1, 0, 1, 0. So how will I make my integers? The first integer would be simply n, nothing else. So it would be 0, 1, 0, 1, 0. Okay. My x2 would be that I keep the first bit set. So I keep the first bit set, rest I just copy. Okay. My x3 will be, okay, these bits will remain 1, that's for sure. Now let me keep this 0 and keep a 1 here. Okay. And what will my x4 look like? So these bits are 1 for sure. Let me keep these two 0 and keep a 1 here. So that is my idea. Look what I have done. Basically what I have done is I am trying to set all these bits one by one. So here this bit is set, here this bit is set, here this bit is set. I know I cannot have multiple integers where this bit is set. I can have only one integer where this bit is set. So this is the maximum length of the sequence I can have. I cannot have a larger sequence because if I take a larger sequence, then there will come a position where multiple integers will have the bit set, and then the bitwise AND will be not equal to n. Okay, so is the idea clear? Ravi, actually the question said that we need to print the entire sequence, right? So, okay, the number of zeros plus 1 should be the answer, but it's not exactly the same. Let me show you the code once, so it will become a bit clear. There's a bit of catch to it. So here comes the code. Okay, so I take n and m as input, and then this is n is answer is the vector where I will actually print the where I will actually store the result. So I first push n to my answer vector. So because I know that n can also be can always be a part of the answer. Okay. So now look what I've done. Okay, so I can actually skip this part and I can only think about this. So basically my idea is that what do I do? I iterate over all the integers. Okay, so just think, so let me show you the law. So there is a bit of catch to it. Let me explain it a bit. There was one more condition which we did not consider here. That was that xi must lie between 0 and m, right? So xi must lie between 0 and m. Okay, so when you are trying to, so suppose this is n, right? So suppose this is n. So n is 0, 1, 0, 1, 0. And suppose my m is something like this. My m is something like this. M is 0, 1, 1, 1, 1. Okay. So if m is this, note that this integer cannot be a part of my answer. Why this integer cannot be a part of my answer? Because x2 is greater than m here, right? M is 0, 0 and then all ones. X2 is a 1 here. So x2 is greater than the basically my value of m, which violates one condition. So that's x2 cannot be a part of my answer. So whenever you are pushing an integer to the vector, you also need to ensure that the integer you are pushing is basically less than equal to m. If it is larger than m, then you do not need to actually then you will actually not put it, because putting it would violate a condition. So that is what I've done. So basically I have found the new val. So when I'm found the new val, what I've done, I've taken the bitwise OR of n with this bit, with this ith bit. Okay. And then what I've done, I basically check that, okay, if this bit is not set, so if this bit is not set, and after setting, if the value still remains less than equal to m, then I push my answer to less than push this value val to my answer vector. Okay, and this large condition basically ensures that that I do not put that if the bit of m is basically 0, then I do not handle it. So basically this initial condition. So this initial condition, that suppose m is something like this, 0, 0, 0, 1, 0, 1, 0, 1, and n is something like this, 0, 0, 0, 0, 1, 0, 1, 1. So using this large variable, I've just ensured that all these zeros, I do not like include a 1 and then add it to my vector. So this I have tried to prohibit it using the large variable, but uh, this was actually unnecessary. If I do not use this and I just use this part, that I just check that, okay, if the value is less than equal to m, then only I add it to my or push it to my vector, then only it suffices. So you can actually ignore this part, and this part of the logic is exactly important. After that, if I see that, okay, if the size of my answer vector is 1, that means I could not have more than one integer in my vector. So I print a -1. Otherwise, I print the size of my answer vector and the answer vector itself. So is that clear? Okay, great. So if this is clear, let us move to the next problem. Just a second. Okay, so let's move to the next problem of the contest. So this was the next problem. It says that you are given two binary strings A and B of length n. You are allowed to perform the following operations any number of times, possibly 0. So it says that choose any index I and swap the characters AI and BI. choose any two indices I and j and simultaneously swap ai with aj and bi with bj. After this, we need to determine if it is possible to perform a sequence of these operations such that both a and b become palindromes. Okay, so let me explain the problem statement once. So the question says that we are given two strings a and b. Both of them are binary strings. So sequences of zeros and ones. Okay, so these are all sequences of zeros and ones. There are two operations which you can do with these strings. One operation is basically choose some index I and swap these, these values. So basically, if you have a 0 and 1, you can swap them to get a 0 here and get a 0 here and get a 1 here. So this is one operation. So that is basically swap AI with BI. Okay. One more operation which you can do is you can take two indices I and j, and suppose this is my I and this is my j, and you can swap AI with AJ and BI with BJ simultaneously. So that means this AI gets swapped with AJ. So we have a 0 here and 0 here. And this BI also gets swapped with BJ. So I have a 1 here and then a 0 here. Okay. So simultaneously swap AI with AJ and BI with BJ. Just a second. Yeah, swap BI with BJ. After this, the question says that using these operations and applying these operations possibly zero number of times, can I make both A and B palindromes? So can I make both A and B palindromes? So that is the question which is asked. So is the problem statement clear? Okay. So let us try to visualize this. So look that both these operations are actually pretty interesting. So what my initial idea with this problem was that do not think A and B as independent strings. Okay, so suppose these are my strings A and B. Don't think of them as independent strings. Rather, think every character as a block. Okay, so think every character as a block. So what is the benefit when you think every character as a block? So basically, I'm not independently treating the ith character of A. So I'm not independently treating this AI and BI, but I'm treating both of them as a block. Why? Now think about the two operations which you need to make. So the first operation says that you can swap two characters inside a block, right? So you take one block and you can swap two characters. Okay, so if the block is 0, 0, or if the block is 1, 1, then swapping does not make any sense at all. If it is 0, 1 or it is 1, 0, then you can actually swap it to make vice versa. Okay, so that was my first operation. What was my second operation? The second operation said that you choose I and j and you simultaneously swap AI with AJ and BI with BJ. But isn't that interesting? That basically means that choose two blocks. Choose two blocks. Say you choose this block and then you just swap these two blocks, isn't it? Because swapping these two characters and swapping this character with this character simultaneously basically means swapping two blocks, isn't it? So basically, the two operations, one operation says that I can basically swap characters inside a block. The other operation says that we can that we can swap two blocks. And what is the final objective? The final objective is that you need to make both the strings A and B as palindrome. Okay. So why do we think A and B independently as strings? Let us think A and B together as a string of blocks. So let me think this thing together as a string of blocks. And now we just need to check that, okay, is this entire string of blocks a palindrome? Like, can we make it a palindrome? So basically, we have initially 0, 1 here, and we have a 0, 0 here. So this is not a palindrome. Can I make it a palindrome? So that is basically the idea, right? And what are the operations we can do? We can swap any two blocks. So and we can change the characters inside a block. Okay. Now think about this. When I have a block, so suppose I have some block. Fine. If both the characters of the block are 0, 0, or if both the characters of the block are 1, 1, then swapping them inside does not make any sense. So basically, operation 1 is useless in this case, right? Operation 1 is useless. And now, if I have a 0, 1, or if I have a 1, 0, I can treat them as identical. Why can I treat them as identical? Because if at any time I found that, okay, I found a 0, 1 and a 1, 0 and they are not matching, then I can swap this 1, 0, this 1, 0 and convert it to 0, 1, right? So I can consider them as identical when we try to check palindrome conditions for the entire string. Okay. So now what is the equivalent problem? The equivalent problem is that I have bunch of blocks. I have bunch of blocks. These blocks look like 0, 0 blocks, 1, 1 block, a 0, 1 block. Okay. I may have 1, 0 blocks, but then I write 1, 0 blocks as 0, 1 blocks only because those are identical. I can use one operation to make them identical. Okay. So like this, I have a string of blocks and I need to check that, okay, can I make this string of blocks a palindrome or not by simply swapping them up. So basically I can reorder this sequence of blocks and then I need to check that, okay, can I make it a palindrome or not? Okay. So this is a very simple question and it has appeared in many forms. So the simple idea is to check the frequency. Okay. So if n is even, so that is basically the length of the strings are even, then the number of 0, 0 blocks, the number of 1, 1 blocks, and the number of 0, 1 blocks, they all should be even, right? And if n is odd, then exactly one of them should be odd. Rest should be even. Right? So is it clear? Like, is the condition clear? Like the way we think about the problem. So basically, instead of thinking A and B as independent strings, we think of them as we think both of them combined as string of blocks. And then we just need to ensure that, okay, this string of blocks is a palindrome. So if I need to ensure that this string of blocks is a palindrome, so what if n is even? If n is even, so this is basically, how do we say that, when do you say that, okay, a string is a palindrome? So basically, if I have a string and then I say you that, okay, how can you rearrange the characters of this string to make it a palindrome? Then what is the condition? So basically, if n is even, if the length of the string is even, then the frequency of all characters in the string should be even. And if the length of the string is odd, then exactly one frequency of one character should be odd and rest of them should be even, right? So that is basically what I've done. Let me show you the code once. So this is the code. So I take n as input, the strings a and b as input, and then I try to find out the count of the blocks. Okay. So what is score? Score is basically ai minus 0 plus bi minus 0. So basically, if the block is 0, 0, then my score is 0. If my block is 0, 1, then my score is 1. Or if the block is 1, 0, then also my score is 1 because those are identical cases. And if the block is 1, 1, then my score is 2. So I basically, for simplification, use a vector of size 3 and use this score thing to actually find the count of every block. And then I simply check that, okay, if n is odd, then the number of count. So basically, if the n is odd, then only exactly one integer should have odd count. If there are more than one integers with odd count, then I set pal to false. And similarly, if n is even, then all of them should be even. If any one of them is odd, then I set pal to false. And after this, if I see that pal is true, then that means, okay, we can make it a palindrome, otherwise we cannot make it. So this is the idea, pretty straightforward. Any doubts with the problem? Okay, so if it is clear, let us move to the last problem of the contest. We will discuss the easy version. Okay, so here it is. So the question says that the Mex-P of a non-empty set S of positive integers is defined to be the smallest prime number that doesn't divide at least one element of S. For example, Mex-P of this, Mex-P of 4, 2, 8 and 16 is 3 and Mex-P of 30 and 210 is 7. So now the question says that we are given a tree with n vertices. Vertex u has the integer au written on it. For two vertices u and v, we define f of u comma v to be the Mex-P of the values written on the unique simple path between u and v in the tree. Okay. And the question is that for each u between 1 and n, we define bu as this sum, and our task is to compute all the n values b1 to bn. Okay, let me explain the problem statement once. So the questions first of all defines this term Mex-P. Okay, so it says that Mex-P of a bunch of numbers. So suppose I have Mex-P of a bunch of numbers, say 2, 4, 8 and 16 is basically the smallest prime number, which does not divide at least one element of Mex-P. So think about all the prime numbers. Let's start with 2. Look that 2 divides every one of them. 2 divides 2, 4, 8 and 16. So 2 divides every one of them. Okay, so get rid of 2. Now think about 3. So 3 does not divide 2 say for per se. So what is the Mex-P of this set? This set is 3. Why? Because 3 is the smallest prime number which does not divide at least one element of this set. Okay. Now think about what is the Mex-P of 30 and 210. So the idea is again simple. Think about all the prime numbers. So first of all, think about 2. 2 divides both of them. So forget about 2. Now think about 3. 3 also divides both of them. So forget about 3. Think about 5. 5 also divides both of them. So forget about 5. What about 7? 7 does not divide 30. Even though 7 may divide 210, but 7 does not divide at least one element in the set. So the max of this set is 7. Okay, so what is the Mex-P of a set of numbers? It is the smallest prime number which does not divide at least one integer in the set. Okay, so for the sake of an example, can anyone of you tell me what is the Mex-P of the set, say 6 and 15? What is the Mex-P of this set? Anyone? Exactly. So the Mex-P of this set is 5. Why? Because 5 is the smallest prime number, because look at 2 and 3. Look at 2 and 3. Both 2 and 3 basically divide both these numbers in the set. So 5 is the smallest prime number which does not divide at least one element, which is 6 in this case in the set. And that is the reason we say that, okay, the Mex-P of this set of numbers is 5. Okay. Now what is the easiest check? What is the easiest check? How can we check? How can we find out the Mex-P of a set of numbers? So suppose I have a large set of numbers. How can we find the Mex-P of such set of numbers? Any idea? So suppose I have a large bunch of numbers and I need to find out the Mex-P of this set of numbers. So first of all, my idea is that, okay, if there is a prime number, say 2, and 2 divides every one of these numbers, that means 2 must be a common factor of this set of numbers, right? Similarly, 3 divides every one of them. So that means 3 also must be a common factor of this set of numbers. So if I have a bunch of, suppose I have these prime numbers p1, p2, and it goes till pk minus 1, and then I have a pk. Okay, and suppose pk is my Mex-P value. Okay, so that means all these numbers p1 to pk minus 1, all of these numbers actually divide all the numbers in the set. So that means p1 to pk minus 1, that must be a common factor of the set, right? Of all the elements in the set, it must be a common factor because it divides all the numbers in the set. So my idea is that, okay, that means if I consider the HCF of these numbers, if I consider the HCF of these numbers, like if I have a bunch of numbers and I consider their HCF, then all these numbers p1 to pk minus 1, all of them must divide this HCF, right? Like think about this. Take 6 and 15. What is the HCF of 6 and 15? The HCF of 6 and 15 is okay, I made a mistake here. Just a second. It was not 5. Sorry for the mistake. Here, we did a mistake here. Look about 2. Like, look at this 2. 2 does not divide 15, right? So that means the Mex-P of this set of numbers is 2. It should not be 5. It should be 2. Why 2? Because 2 is the smallest prime number which does not divide at least one element in the set. 2 does not divide 15. So 2 is the smallest prime number which does not divide at least one element in the set. So Mex-P should be 2 and not 5. I apologize for the mistake. But okay, so what was my idea? My idea was that you think about, okay, so let me take a new example. So the question which we were discussing, the example which was given in the problem. So think about Mex-P of 30 and 210. We already know that Mex-P of 30 and 210 is 7. Okay. So think about the bunch of prime numbers which we have. It is 2, 3, 5, and 7. Okay. And it goes on. And what is the HCF of 30 and 210? The HCF of 30 and 210 is 30 itself. So my idea is that, okay, 7 is the Mex-P of these numbers, right? So that means think about all the smaller primes, 2, 3, and 5. 2, 3, and 5, all of them must divide 30, the HCF. Okay, so that is clear. So now let us come back to the problem statement. So the problem statement says that define f of u comma v. So we are given a tree as input. Okay, so we are given tree as input. So we know that whenever we have a tree, then there is a unique path between two vertices u and v. Okay, so there is a unique path between two vertices u and v, and there are integers labeled for every vertex. So there is an integer labeled for every vertex. F of u comma v is nothing but the Mex-P of all these integers in the path AU to AV. So that is what f of u comma v is. And they say that, okay, BU is nothing but the sum of this f of u, sorry. So BU is the sum of f of u comma v for all v. So you basically iterate v from 1 to n, keep this u fixed, and this is basically my BU. And we need to print all the values of BU from u equal to 1 till n. Okay, so is the problem statement clear? Is the question clear? Okay, fine. So if you look at the constraints of the problem, it says that the sum of n across all tests won't exceed 2000. That means a big O of n square or a big O of n square log n solution would accept, like would give AC. Okay. So now think about this, that we need to print n integers b1 to bn. Okay, and an n square solution will get accepted. So individually, so let us try to individually try to solve subproblems of this problem. Okay, so let us try to find out the value of bu. Let us try to find out the value of bu in, say, some order n or order n log n time. Okay, and then we can independently do it for all the vertices u from 1 to n, and it would finally yield us a big O of n square or n square log n code. Okay, so how can we find out the value of bu? How can we find out the value of bu for some node u? Okay, so I have some node u, and then there is some tree associated with it. And suppose I've rooted this tree with respect to u. And the question is simple. I basically need to find the value of bu. Okay. So what does that mean? So that means that I need to, for every v in this tree, I need to find out the sum f of uv, right? Like if you recollect what is bu, bu is nothing but the sum of f of uv for all v from 1 to n, right? So that is what my bu is. So I need to find out the sum of f u comma v for all values of v equal to 1 till n. Okay. So remember that what I can actually do is I can do a plain DFS to find out the HCF. So for some v, I can actually do a plain DFS in order n time to find out the HCF of the, so in v dpv, I can actually store the HCF of the path from u to v. HCF of path from u to v. How can I store? Like this is simple dynamic programming on trees. So that is basically that if there is a parent, and suppose this is a child, okay, and I have this dp value already calculated here. So I have dp parent calculated here. So dp child, so that is basically the HCF of every node of every value from child till the root u would be simply the HCF of dp parent and the value of the child, right? So a child. So that is basically if I try to find out the HCF of all nodes, HCF of all nodes in this path from V to U. So that is basically the HCF of this node of this child, and then I use the value of the parent to find out the HCF of the remaining path. Okay. So using this, we can use simple dynamic programming on trees to actually find out the HCF of the path from U to V. Okay. So if I found out the HCF of a path from U to V, so suppose I have a bunch of numbers. So that basically means I have some bunch of numbers and I found out their HCF. If I've already found out their HCF, let me call this G. How can I find the Mex-P of this bunch of numbers? Like, can I use this HCF to find out the Mex-P of this bunch of numbers? The simple idea is that you iterate over the prime number list, right? So you simply iterate over the prime number list 2, 3, 5, 7, and so on, right? And you just check that, okay, is G divisible by 2? Is G divisible by 3? Is G divisible by 5? And so on. The first time you find out G is not divisible by some integer, say G is not divisible by 7, that means 7 is the Mex-P of this bunch of numbers. So 7 is the Mex-P of this bunch of numbers. Okay. So now we know that if I can find out the HCF, then we can actually iterate over the prime number list and check that, okay, what is the Mex-P value? But will it not become slow? So will it not become slow if I iterate over the prime number list? There are many primes, right? So will that not be a problem? Anyone? Like if I iterate over the prime numbers entire list and check for every prime number, like is the HCF divisible by 8, will it not be a problem? Okay. So if you think about it, then you will realize that Mex-P values are not very large. Mex-P is not large. Why so? Because think about this, that when you are actually multiplying prime numbers, so it is given that the values of AI is less than equal to 10 to the power 9. That is given in the question. So now, so that means the HCF of all these numbers would also be less than equal to 10 to the power 9. That's for sure. Okay. So now you are iterating over the prime list one by one. So suppose you have you keep on iterating. Okay. And so on. So remember that so suppose when will you break? So after how many iterations you will at most break? So HCF is divisible by 2, HCF is divisible by 3, HCF is divisible by 5, HCF is divisible by 7 and so on. But remember that this loop will actually have to be break very quickly. Why? Because the product of prime numbers actually rapidly increases. Like if you think about this, the product of all the prime numbers till 29, even if you consider all the product of all the prime numbers till 29, this exceeds 10 to the power 9. Okay. So that means this list will not exceed much. Like using just, so 29 is the 10th prime number. So that means you have to iterate at most 10 times. Within 10 times, this value will exceed 10 to the power 9, and you will surely get one prime number such that HCF is not divisible by that prime number. That is the reason why this approach actually works. You can actually iterate, walk upon the prime number list and check which prime number is not divisible by G or which prime number is not divisible by HCF, because because the product of prime numbers increases so fast that you will very quickly get a prime number such that the HCF is not divisible by the prime number and the loop will break. Okay, so do you get the idea? Okay, so let me show the code once. So here is the code. The idea is simple, that I first take AI as input, then I take the tree as input. So I take n minus 1 edges as input. Okay. And after that, I do basically I iterate over all the vertices I from 1 to n. So basically at the ith iteration, I will try to compute the value of bi. When doing so, I first update all the values of dpj with aj, because I know that, okay, what would be dpi store? DPI would store the HCF of the path from AI till the root. Okay, so I store DPJ with AJ, and finally later in the DFS I will try to take the GC or GCD of this value with the DP of the root. Okay, then I do a DFS. While doing the DFS, I just ensure this simple thing, that when I'm trying to go finding the DP of the child, that is nothing but the GCD of the DP of the parent and the value at the child. Okay, so this is a simple DFS logic. After this, once I've used this DFS or DP on the trees to compute the GCD of every node, of the value of every node from the node itself to the root, after that I compute the answer. While computing the answer, what do? I simply iterate over the prime numbers list, and I check that, okay, is DPI divisible by P? If DPI is divisible by P, if DPI is not divisible by P, then I have found out the Mex-P. I add it to the sum and I break the loop. Okay. So this is my prime factor function, which basically computes the prime number list and nothing else. So this is a part of my template code, which is pretty simple. So apart from this, so this is the basic logic, that you basically find the GCD and then you iterate over the prime numbers list to find out which is the maximum, like which is the smallest prime number which does not divides the GCD. Okay, so is the idea clear? Any doubts with the solution? Okay, great. So that was all from my side. Thank you. Let me close the recording.